Today we are going to start a chapter that's combustion and flame. Topics involved in this chapter are introduction, then what is combustion, then we'll discuss combustible and non-combustible substances, then ignition temperature, then fire control, types of combustion, flame, structure of flame, then we'll discuss fuels and efficiency, and at last concerns with burning of fossil fuels. So let's start the introduction part. Have you ever ignited a matchstick or have you seen the candle burning? You must have used the Bunsen burner in your chemistry lab to heat substances or chemicals inside the test tube, or your gas burner, in fact, inside your kitchen, which is used for cooking. When you try to burn wood or coal, what happens when we burn these substances? What do you see when a candle is burning? What do you see? We see the fire. We see this flame of candle. It's visible, right? Similarly, when a Bunsen burner is on, we can see the flame again. When you burn wood, you can see the fire which is being produced. The gas burner, when switched on, you can see the flames. Now, if you look at all of these flames, fires, they all look very different from each other. Do you think the flame of candle and the flame out of this gas burner, both of them look similar? No, even their color, appearance is different. So now in this lesson, we are going to discuss all about burning, how this process of burning takes place. Now, what we call burning in common terms is what is known as combustion in science. So let's start with what is combustion. It is a process in which a substance reacts with oxygen to release heat and light. That's what we actually see, flame or fire in different substances. So now what happens when you light a candle? You see a fire, right? Because of that fire, that gives heat and light. You can think combustion as the process of burning. But how do we define this process scientifically? Because now what exactly is happening inside that so much of heat and light is produced? Now, basically, all that is happening is the substance is reacting with oxygen, and after reacting, you can say combustion has taken place. So, combustion takes place when oxygen is present in the surrounding. If there is no oxygen, there will be no combustion. So, this is combustion, reacting of a substance with oxygen to release heat and light. Now, when we talk about release of heat and light, it, it's not necessary that light has to be released during the combustion of all the substances. Light may be released, light may not be released. Now, if light is released, light can be released in the form of a flame, in the form of a glow. For example, if you try to compare the process of combustion in candle and coal, if you burn both of them are reacting with oxygen, and due to that reaction, lot of heat and light is being produced. Now, in case of coal, you really do not get fire, flame. You can see just a reddish glow on the coal that happens due to combustion. Whereas in case of a candle, you can very distinctly see the presence of flames. So it depends how light gets emitted in different substances. Now again, it's also not important that all substances on burning release heat. We can say that not all substances undergo combustion. If you take example of a matchstick, do you think a matchstick undergo combustion? Yes. How do you ignite a matchstick? You have to rub it, right? Or strike it against the side of a matchbox. Then there's friction, and where there's friction, there's heat, and the matchstick ignites, and you can see the flame of the matchstick, right? So this is a combustible substance, right? Because combustion takes place in this matchstick undergoes combustion. Now, what are combustible substances? Those substances which undergo combustion. That is, they burn easily to release heat and sometimes light. So the combustible substances are the ones which undergo combustion. They burn easily and they release heat and sometimes light. So just now I was talking and I was telling you that not all substances undergo combustion. Those substances which can burn to release heat are called combustible substances. They undergo combustion. For instance, if you take an example of a paper, it can burn very easily and releases heat. You can take the example of petrol, diesel. They very easily catch fire. That is why in petrol pumps people are not allowed to smoke because the chances are very high that if somebody leaves burning cigar or matchstick there, so chance of petrol catching fire is very high. If you take an example of a magnesium powder or aluminum powder, or you can take the example of a paint. All these are the combustible substances. They all catch fire, they all burn easily. Even most of the metals, as such, like iron, they are not combustible. They do not burn to release heat. But some metals in the powdered form, like aluminum powder, magnesium powder, in the powdered form of some metals are combustible. That is, they get burned to release heat. So these are all examples of combustible substances. They all undergo the process of combustion in different ways. Some of them will produce huge fires, some of them will produce flames, some of them just show glow. On the other hand, we have a set of non-combustible substances which do not undergo combustion to release energy. So they will not get burned to release energy. Let's look at some examples. See, most of the metals, I told you that they are non-combustible. Okay, like iron nail. It's made of iron metal, so it's non-combustible. If you put it on fire, do you see that the iron nail burns? Nothing happens to the iron nail. It doesn't burn. So that is why it's not a non-combustible substance. Similarly, if you take example of a glass, glass do not burn. You can take the example of a steel, like you are having steel spoon, stones, rocks. They're all examples of non-combustible substances. Thank you.